Welcome everyone to lesson 3.6 of Precalculus, which is all about transformations of those sinusoidal functions we learned about last class. So this is the combination of things that we've learned from Unit 1 and things we've learned from Unit 3 and clashing together. So let's get started. To describe all of our possible transformations that we could have on the sine and cosine functions, which are our sinusoidal functions, we get this a times sine of b times x plus c plus d. Now, keep in mind that the b is factored out. That is super important that the b is factored, because b is going to affect what c is if it's not, and you have to play around with that. So if it's not factored already and you're trying to describe transformations, factor it. Cosine, same exact way, and has the same exact effects. Now, here's an important note. These sinusoidal functions are the first time that every single different transformation reacts differently with our functions. Before, with our polynomials, if we did a vertical dilation or a horizontal dilation, well, you could describe one in terms of the other. If I dilated it by 2 vertically, it would be a different dilation. I could do a different dilation horizontally and arrive at the same result. If I talk about exponentials and logs, translations turned into dilations, which was really, really cool. But for our sinusoidal functions, every single transformation affects the graph independently, you could almost say. So the A, and these are the same as what we've been doing, really. The A is your vertical dilations and reflections. Your B is your horizontal dilations and reflections. Your C is your horizontal translations, and your D is your vertical translations. So what you're used to, right? These are the major 4 ways we've modified functions before, or 6 ways, depending on how you want to count it. So if we use our wave vocabulary, if we use our periodic vocabulary with these 4 modifiers, what does that mean for our amplitude and so on and so forth? Well, the amplitude is the absolute value of A, which we did talk about last class, right? We talked about that during our introduction to sinusoidal functions. So that doesn't really change. The midline changes. Your midline, which is default 0, changes to however you shift the function. If you shift the function up 2, the midline's now 2. Shift it down 5, midline's now -5. That makes sense. The period we had before, period was 2 pi. That was it. That's how it was, and we went on with that. If I dilate horizontally now, I'm changing how often those cycles occur. And remember that when you dilate horizontally, it does the opposite effect. So if I multiply by 2, it's shrinking by 2 and not expanding. It's happening faster, if you want to think about it that way. So if we're going around the circle, which we are, we multiply by 2, we're going around twice as fast. If we're multiplying by half, we're going around half as fast. So our period is 2 pi divided by our dilation coefficient, our scale factor, if you will. Our frequency is the reciprocal of that. So instead of 2 pi divided by b, frequency is b divided by 2 pi. A little bit more to memorize, but make the connections. If you relate it back to what we've learned about previously, it's not nearly as bad as it seems. And I promise you, you might even think it's fun. But you might be crazy like me, so, we'll see. So let's graph some sinusoidal functions and then describe some behavior. So let's describe behavior first, because the behavior is going to determine how our graph is going to look. So if I have 3 times sine of 2x, well, the amplitude is, 3, right? The absolute value of 3 is 3. The period is equal to 2 pi divided by b. In this case, b is 2. 2 pi divided by 2 would be pi. So instead of repeating every 2 pi, it's repeating every pi. It's repeating faster. Our midline is y equals 0. So mid is y equals 0. Our frequency is the reciprocal of our period, so it would be 1 over pi. No use in doing that math over again. Our max value would be 3. Our min value would be -3. And I do believe that is all we really need to describe. So this is great. We have all of this information. How do we apply that to the graph? Well, what's sine's behavior? Sine's behavior is up, middle, down. No, that's cosine. Mr. Whaley. It is middle, up, middle, down, middle. Well, the ups and the downs are going to be extended because of the 3. But this is all happening twice as fast because of the 2. So instead of the start and the end being 0 and 2 pi, it's going to be 0 and pi. And everything, again, is nice and evenly distributed. So sine, let's get out the red, because that shows up pretty well in graphs. We're going to do 0, and it ends at 0, right? So it goes middle, up, middle, down, middle. So it starts at middle and ends at middle. And the direct middle of those 5 was a middle again. So we're going to put a middle again. In between the first 2, we went middle, up. So that is going to be up 3. And then middle, down. So that is going to be down 3. And then we get back to the middle. So this is one period of our sine curve. So that's one cycle. Now we just infinitely repeat and copy and paste that both directions until we fill up our graph. So we're going up, middle, down, middle, and that completes the right-hand side. On the left-hand side, we're going to do the exact opposite order because it's odd, remember? So down, middle, up, middle, down, middle, up, middle, and we get this curve right here. Oh, it does that sometimes. Perfect. Beautiful. Easy breezy, beautiful cover girl, right? It's essentially not that bad. So just a few more modifications. So let's go through this one here. Our amplitude is 2. Our period is equal to 2 pi divided by 1/2 would be the coefficient there, divided by 1/2. Remember that dividing by half is the same thing as multiplying by 2, so it's 4 pi. It's repeating less often. It's going around the circle slower. Our midline is still y equals 0. Our frequency is going to be 1 over 4 pi. It's not going to repeat as often. Its maximum is going to be 2, and its minimum is going to be -2. So 5 key points for cosine: up, middle, down, middle, up. We have negative coefficient, so it's down, middle, up, middle, down. And we're starting and stopping at 4 pi. Oh, we don't have enough space. Let's write what we have. So we're going down 2 to start. And if I think about cutting this up into 5 pieces, I would have 0, pi, 2 pi, 3 pi, and 4 pi, right? So let's go with the pattern as much as we have. So it's down, middle, up. That's all I got. But cosine is even. I can reflect that. So that at least gives me one full cycle within -2 pi and 2 pi of this cosine curve. So it's stretched out because it's going around the circle slower, right? So that makes sense. Let's throw in changing the midline. How does that affect things, Mr. Whaley? What makes things a nightmare? No. They're not bad. Let's go through step by step like we did before. The amplitude is 2. The period is 2 pi divided by 1/2, which we know is 4 pi. The frequency would be 1 over 4 pi. The midline would be y equals 1. So not the mind, the mid. The mid is y equals 1. The max, well, if the middle is 1 and the amplitude is how far we're going away from that, the max would be 3. Because 2 above is 3. 2 below, though, is -1. So I changed things a little bit. Something else I'm going to do that's going to be a little bit different is I'm going to make a dashed line at y equals 1 just so I can visually see where the middle is. It doesn't have to be bold. It doesn't have to be huge. Just visual indicator. That's the middle. So by all that, let's see what we got. We got a sine. So sine, remember, is middle, up, middle, down, middle. But we don't see the whole picture because, again, the period is 4 pi. But we're cutting it up into equal chunks. So we have 0, pi, 2 pi, 3 pi, 4 pi, right? So sine is going to start at the middle, then it's going to go up, then it's going to hit the middle again, and then it's going to do the opposite. Remember that we're rotating this around the origin, so it's going to go down and then hit the middle again. So we get this nice elongated sine curve, which looks very straight. If yours looks straight, that's, homophobic. It should be a nice, beautiful curve. And we can kind of see that it's 2 below, 2 above. It works out, right? Not that scary. K is a little bit different. What's different about K? If you're screaming at me that it's not in the right order, you'd kind of be right. Let's rewrite it in a way that's nicer for us. -4 cosine of 2x plus 3. That way we can kind of see each piece and see what each piece does. The amplitude is 4. The midline is y equals 3. The period is 2 pi divided by 2, which is pi. So the frequency is 1 over pi. The max, well, the middle is 3. The max would be 4 more than that, so the max is 7. The min would be 3 take away 4. That would be -1. So again, I'm going to draw a little dashed line at 3. And then I'm going to think about this cosine function. So this cosine, remember, behavior naturally up, middle, down, middle, up. It's negative coefficient, so it's going to be reflected down, middle, up, middle, down. So it's going to be at its minimum here, which is -1. And then the period is pi. So it's going to be back at -1 at pi, and then every whole pi is going to be back at -1. In between the two minimums is the maximum, which is a little off my graph, so just bear with me on that. And then in between the max and the mins, it hits the midline. It hits the middle. So we get this. As far as dots go, what does it look like entirely? Well, we just got to do our best to recreate that. Nope, it did it again. There we go. So we get that kind of curve. It's repeating more often. It's flipped. It's translated up. Great. So that is 3 of the 4 major ways we're going to modify these functions, right? What have we not talked about yet? We haven't talked about horizontal translations. So horizontal translations is where this gets a little bit more difficult. We're going to crank the difficulty up a little bit. And one thing to note, it's a vocab word, is that when we horizontally translate these functions, we call them phase shifts. Think like phases of the moon is periodic, so phase shifting. This is determined by the C we talked about before. Remember to factor. If it's not factored, you have to do it yourself. So if we look at these and we're identifying everything that we identified before in addition to the phase shift, it's not bad. This one here has no coefficient for the x, so there's no factoring we have to do. Brava. So the amplitude is 3. The period, we just used a p for that. Let's keep it consistent. The period would be 2 pi divided by the b. There is no, well, the b is 1, yes. So that would be 2 pi. The frequency then is very nice. It's 1 over 2 pi. What do we have next? The midline. The midline is y equals 2. The min value, or the max value, let's start with that. The max is 3 plus 2, which is 5. The min is 2 take away 3, which is -1. And the last one is a phase shift. I see a plus pi over 4. So we're going to go pi over 4. The plus, remember, if it's happening to the x, it does the opposite. Plus makes it go left. So left pi over 4. So when I start this cycle for cosine, which again is up, middle, down, middle, up, I'm starting that cycle pi over 4 to the left of 0. So let's paint a picture with all this information. So our midline is 2. Let's draw a dashed line at 2. Our period is 2 pi, so that's nice. We're pi over 4 to the left. Cosine starts at its maximum, which is at 5. So pi over 4 to the left, maximum of 5, 1, 2, 3, 4, 5, would be here. Now, the period, again, repeats every 2 pi. So 2 pi plus negative pi over 4 would be 1 less than 2 pi. Directly in between those, directly in the middle, is the minimum, right? Directly in the middle used to be pi. It's going to shift over to the left one, and that is a minimum of negative 1. Used to be negative pi. Now it's going to be the left one. It's pretty good. And then in between those, directly in the middle of those, is where it hits the midline. So directly in the middle of those would be the midline. So if we draw our curve, we have something like this. Oh. There we are. So again, it should be nice and smooth. It's a little hard to do on a tablet, so do your best with it. But it's not that bad. You just have to think of where you're starting, where you're ending a little bit more. Again, use those 5 key points. If you're using that 5 key point method, it makes everything a little bit more smooth. Let's try this one. We got a lot more going on here. I spy with my little eye the fact that it's got a coefficient on the x and it's not factored. Let's do it. Negative 2 sine of 2. And I like to use braces either on for the sine or the one on the inside. Doesn't matter, just so I have the differentiation. X minus pi over 2 minus 1. Now we can clearly see what each and every value is doing and how it's affecting our graph. So our amplitude is 2, because the absolute value of negative 2 is 2. Our period is 2 pi divided by 2, which is pi, so it's happening more frequently. So its frequency is 1 over pi. Our midline is y equals negative 1. So it's the first one we're actually going down, I believe. Our max value is negative 1 plus 2, which would be 1. Our min value is negative 1 minus 2, which would be negative 3. That's a 2. And finally, our phase shift, we are going right because it is a minus, and then pi over 2. So we're shifting everything. Our start is starting at positive pi over 2. What are we dealing with? We're dealing with sine. So remember, our pattern for sine is middle, up, middle, down, middle. Negative coefficient on the sine. We're flipping that. Middle, down, middle, up, middle. And we're starting at pi over 2. So pi over 2 is the middle. Let's write our midline first. So pi over 2 is the middle. And our period is pi, so we're going to hit the middle again every pi before and after. And remember, it's middle, down, middle, up, middle. There's a middle in between the two middles, so every whole pi is also going to be a middle. Remember, this is where we're starting, right? And from the first middle, we go down, middle, up, middle. So we're going to go down, middle, up, middle, down, middle. Repeat the pattern backwards because it is an odd function. Up, middle, down, middle, up. Nope, I missed. Up, middle, down, middle, up. And then we can finally put everything together and get this beautiful sinusoidal curve. Nope, they don't want it. I don't know why it tries to delete everything every time. But that's what we get. Not bad at all. Honestly, I think it's quite fun, like piecing puzzle pieces together, trying to figure out what's happening to this function. So that is taking a function and drawing its graph. What if we're at McDonald's and we're doing a function made to order? So we want a sine function with an amplitude of 3, a period of pi, a phase shift left of pi over 8, and a vertical shift down 4. So we know we have to modify the function with a, b, c, and d, right? What do we know? We know that the absolute value of a is equal to 3. The period is pi. Hold on to that. Phase shift left, pi over 8. So if we're going left, we're adding. So c is equal to positive pi over 8. And we're vertically shifting it down 4. So the thing we really have to find is b. So we know that the period is equal to 2 pi over b. The period is pi, so pi is equal to 2 pi divided by b. Pretty easy solving. You should figure out that b is equal to 2. And for our intents and purposes, it doesn't really matter. You could make the a positive or negative 3. It doesn't matter. I'm going to make it positive, just being nice to myself. So we have f of x is equal to 3 sine, and I'm going to use braces to differentiate, of 2 parentheses x plus pi over 8 braces minus 4. And that is a function that meets all of those criteria. There are other functions you could write, but keep it as simple as you can. Like, there's no reason to pick a different c value, even though you could phase shift it an infinite number of different ways. Make it as simple as you can. Don't be hard on yourself. Last but not least is, let's do the opposite. I have a graph, and I want the function for it. Well, let's identify some behavior, shall we? First of all, the minimum value is negative 3, and the max value is 1. The middle of that is negative 1, so this has a midline of negative 1. So if I go A, B, C, D, I know that D is negative 1. Awesome. I also know the difference between the midline and the maximum is 2. And it wants a positive leading coefficient, so it's saying A has to be 2. Phase shift. It wants a sine curve. Remember that sine by default is middle up, middle down, middle. So middle up. It goes from middle up here, right? So this, we're going to say, is our starting point. So that point isn't at 0, though. It's at pi over 4 to the right. So this is going to be pi over 4, but right means negative. Last but not least is the period. Now, the easiest way I can tell you to identify the period is you look for, do you have 2 maxes or 2 mins showing? We have both, so pick one. I'm going to pick the maximums just because. There's no rhyme or reason for me picking the maximums. And then what I'm going to do is I'm going to take the max value, which is 3 pi over 4, and I'm going to take away the smaller one, which is negative. In between these would be 5 pi over 4, which means that I'm adding these together. 3 plus 5 is 8. 8 divided by 4, 2 pi. And we can check that. The length of 2 pi is 1, 2, 3, 4, 5, 6, 7, 8 squares. And I have 1, 2, 3, 4, 5, 6, 7, 8 squares. So the period is actually 2 pi. It didn't change. So the b is equal to 1. So we put all this together. I get f of x is equal to 2 sine, because it wants a sine graph, of, well, I don't really need to do that because the b is 1. So x minus pi over 4 minus 1. And that is it for this lesson. If you have any questions, please let me know. Otherwise, I'll see you in the next video.